the particular sunflower seed and the spirals that you see in the sunflowers, any sunflower that you take follows a particular number. So this follows a number called Fibonacci series. Though Fibonacci name is more popular, but the original inventor of this particular series is Pingala. Is somewhere sometime in second or third century before Christ, almost 2000 years ago. Of course, Fibonacci made it more popular, but otherwise this is originally found by sage Maharshi Pingala is what they call, right? So when you observe nature, it follows this particular number. Even the petals in particular daisies, they follow this particular Fibonacci series. So nature is completely artistic and very highly creative in terms of this, how it helps us. So this particular slide, as for biomimicry, I think these are the people who are the recipient of $100,000. They got a 2022 Ray of Hope Prize. This biomimicry has got a prize with a global competition based on who are the people who are inspired by nature, are able to give a real world solution. In this particular case that you see here, when you box and control especially when you ship the mangoes, so the raw mangoes are in a semi-raw state or shipped. So in about 10 days, that starts rotting. So this particular problem was observed by these two people called Greenpond, people who are the originators in Greenpond Labs, and they studied how nature is able to solve. Nature is able to solve this problem of rotting basically because by creating certain gases on the surface, it is able to avoid this rotting. So these people, what they have done is they picked up those, observed it, and they picked up that particular chemical from the plant. Enzyme it is actually by enzyme, and putting it in a sachet. What you see here is their sachet here, right? So they put one sachet in one of these boxes, and you will see in 10 days all of this one where the Greenpond Labs sachet was put, there is no rotting of these mangoes. So thereby extending it for almost about 40 to 60%. The shelf life of mangoes is extended. So that helps save almost 30-40% of the losses. So the economic loss of the food waste, it costs close to about $12 billion in India. So this is what has been highly innovative and creative idea that they got by looking at nature, how nature works to ward off the rotting and other things. So this is one such example. So we'll look at another such examples. What is learned from nature are this, that from the lotus leaves. When you observe the lotus leaves in water, water doesn't stick to the leaf at all. It's something like it starts jumping on the leaves and then falls off. Have you observed this?
Srishti, have you observed that?
You can keep your mic unmuted, no issues, because not all of them are unmuting, right?
Yes, sir.
So it doesn't stick. The water doesn't stick to the leaf. Why? How does this happen? This was observed by when you observe when you see these piles inside the leaf, it has got nanopiles, like pillars, sharp nanopiles. So when these nanopiles are simulated on your cloth or any other material, the water doesn't stick. This is exactly the technology that used by creating these nano surface heads or surface piles. So what we observe in today's hydrophobic piles, that is water resistant thing. Most of you people, especially in outdoors and all that, you would have used this, right? It's called dry fit and all of that.
Yes, sir.
This kind of cloth, right? So this particular example, of course, is from amphi-dry yarn. So this particular yarn itself is made to have this nano piles, so that the water doesn't stick to it. So this is something which is learned from nature. Otherwise, what they used to do earlier, before this, they used to coat the particular cloth with a chemical. Again, chemical is one is using a chemical is harmful for nature, and second problem is disposing such cloth is again another. It's like also harmful for nature because it goes back to the soil, right? So by this method, without doing any coating, they're able to have this property of hydrophobic, that is water repellent properties. So this is again learning from nature. So now this product has become reliable and highly environment friendly. It is recyclable, it is waterproof, it is breathable because it is just sort of There is no coating in it, and it is completely chemical free materials. That's the advantage of learning from nature and how nature does things. This is another interesting application of learning from nature. In generally, whenever we see particular colors, right? Whenever we see colors, what is used? Can any of you guys answer? Unmute and answer. Whenever we see color, what is used to get the color? In probably almost close to 100% of the cases, or 99.9% of the cases. Moment we see color, what do we see? How do we get color? If you can make this interactive, it will be good, na? Any of you?
Any student, please interact the session.
Otherwise, it will be just like your class.
So prism is a one example where we'll get a colors and
Correct. But that is by splitting light, right?
yes, sir.
But yeah, you can say by projecting colors on a prism, you can get colors without any pigments, right? Otherwise, it is all pigments, right?
Yes, sir.
Pigment is a paint. Essentially, wherever we see colors, we want to paint that. So if it is a wall or a window or any particular area, we color it, right? So whichever color that we want. So that again, pigments are again chemicals. Again, they are harmful for nature. Now, how can we simulate a particular surface without using any pigments? This is the study that was done by observing this particular blue morpho butterflies. When this was observed, this blue morpho butterflies, on the outside it looks brown here like this. Are you able to see this?
Yes, sir. We can.
And inside they are blue. So, but generally, when this mosques or moth and all that, when you touch them, that particular pigment sticks to your fingers, right? Few of you would have observed in your younger days when you're playing with a butterfly or a moth. Whereas in this particular case of a blue morpho butterfly, nothing sticks to your fingers when you touch the feathers. So that means there is no coating at all. There is no pigmentation used by this butterfly. Then how does it look blue? How does it get blue? So it is essentially, when you analyze the surface of this particular butterfly, it is consists of this nano, something like a trees. Are you able to see the structure here? This
Yes,
is
sir.
1 micron. Huh?
Yes, sir. We can.
So what happens in this particular structure like this? It is not a flat surface. It has got the 1 micron, something like a tree, very fine micro trees. You can't really make out by naked eye. So what happens with this particular thing is when the white light is reflected on this, the resultant light what it gives out is only blue and nothing else. So it is essentially using white light or a natural light. It's able to produce different light, different colors. So now using this particular technology, so people have simulated using synthetic polymers where there is no colors, there is no dye. It just looks like this. What you see here in this particular picture, it just looks like a clear liquid. But when you paint that particular liquid on any surface, yeah, you get a particular color. So by different structures, you can get different colors. So the advantage is there is no paint, there is no pigment, there is no chemical involved. So it is just a synthetic polymer, essentially. And this creates a nanostructure. That particular polymer creates a structure. That's it. So that structure looks like that color. This is used in IR resistant glasses and coatings and all of that in large buildings. So otherwise they used to use films and or paint and all of that. So that is again learning from nature. Pigmentless coloring. So one other way of another example of nature's learning from nature is to create what is called a DLIP, direct laser interference patterning, by one of the companies called Fusion Bionic. I'm sure there are plenty of companies. Here, what happens is they're able to produce on any surface, metal or all of that, one which can be made into a self-cleaning, one can be anti-icing, that means there are no ice that deposits on the surface, or it could be even antibacterial, and it could be decorative coloring